Good afternoon, everyone. How's everything going? Today, let's discuss about the past year question that we have we have done last time. By the way, may I know how many of you have completed all the questions? So, like what I did last time, I would like to see how many of you have done the question. You, how many questions have you completed? Okay, last time we already discussed question number 2. So let's see question number 1. Let's say 2, 3, and 4. How many of you have completed? Okay, help to vote in the poll. Okay, I see most of you have completed question 4. So let's discuss the answer today. Okay, let me open my pen and share the screen. Okay, by the way, today will be our last lecture. So we are supposed to have some replacement class by 3 to 5 p.m. later. But I think we have completed everything. So I also think that you don't have to attend the class anymore later. So after discuss the past year question today, then we can have a section. So there will be no lecture class, but we still have one tutorial class for each group of you. The tutorial question I have already sent to you earlier. Please do it and we will discuss about the answer by tutorial class. Okay. Okay. So let's discuss about the past year question today. Okay. Consider an element with a value of an effective density in the NC equals to 4.7 times 10 to the power 17 cms cubed. And then MV unknown. Okay, don't know. Both NC and MV vary as a T to the power 3 over 2 band gap energy 1.55 eV. So at first, calculate the MV if the intrinsic carrier concentration and I equals to 1.8 times 10 to the power 6 cm mass cube. Okay, to do this, let's see how we're going to do this. We know that Ni square will be equals to Nc Mv exponential minus 1.55 over 0.0259 if T is equals to 300. Ni is given, no problem. Nc is given. This value is given, so we need to find the Mv only. That's it. Very simple and easy for the first part. So what are the answer? So let me put some guy to answer this. Okay, on mailing, what's the answer for the 2A1? Okay, on mailing give us an answer, and V equals to 6.74 times 10 to the power 21. You guys get the same answer? Wait, let me open back. Oh, sorry, not this. Okay. So, do you guys get the same answer as your friend? Any plus one, or you get a different answer? Han Xiang, what do you get for the MV? Okay, Han Xiang get times 10 to the power 20. Okay, Han Xiang one 6.74 times 10 to the power 20. So I think basically you guys need to check whether this one is correct or not. So anyone get the same answer as Han Xiang? Can you add one? Okay, so I believe Han Xiang could be the correct answer. Okay, so on mailing, please recheck the answer again for this question. So this is the first question. Let's go to the second part. Based on the result obtained from the Q2A1, calculate the new intrinsic carrier concentration at T equals to 400 K. So here's a little trick. Okay, so we need to know that NC and V, then 4 over 3, then supposed to 3 over 2 multiplied by 3 over 2. So when you add these two things together, you will get 3 lah. Okay, makes sense. And then exponential energy gap. In this case, we assume that it will be maintained. Okay, 1.55, 0.0259. So you put NC and MV inside, then you are going to get the Ni square. To get the intrinsic carrier concentration, you need to do the square root. Okay, in this case, what are the answers? So Yan Chang, are you here, So Yan Chang? What are the new Ni? You can write as a 400K. Yes, Mr. So Yan Chang, are you here? Okay, missing action. Lim Yong Chuan. Okay, welcome back. So Yan Chang, what's the answer for the Ni in the 400K? Okay, 7.68 times 10 to the power 12. You guys get the same answer? Any plus one? Lu Jueming, what do you get? Wait, so in Chang, is this a square root answer? Which one is the correct one? I want the Ni, not square. Okay, the answer given by the Lu Jueming is another answer, which is 4.19 times 10 to the power of 9 cm minus cube. Okay, one word for the Lu Jueming. What about the rest? 9-1. Tepat this one, 9-1. Okay, there's a few. One guessing. What do you get? Okay, so I assume that I want to get the answer given by Lu Jueming. Okay, supposedly. Then let's go to the last one. Based on the result and the equation obtained by Q2A, determine the conductivity and the resistivity at T 300K Given the Na is 0, Nd is this, mobility is mu n and mu p is this. Basically, this one very simple. All you have to do is E mu n m plus mu p p. This will become conductivity. Mu n is given 8500 n no. Okay, you can calculate from the answer from above. Okay, mu p is also given. Mu p is given over okay 400. Then p. Okay, what's the p? Okay, so let's see how we're going to do this. So given the ND and NA is given here. So you need to calculate the N, ND minus NA divided by 2 plus square root ND minus NA divided by 2 square plus NI square. And then you can see that this one is ND more than the NA. So this one, you know that the N is the majority. Then your P will be NI square divided by N. You can get the P value. After that, all you need to do is just to replace every single value inside there. Okay. So based on the result and the information, which is the Ni, it means the Ni 1.8 times 10 to the power 6. Okay, so in this case, what are the answer? Your Ni is obtained here, and the Ni given, Ni given, P is calculated. So using all this four information to calculate the conductivity. Wong Ga-seng, what's the answer for the conductivity? Okay, conductivity that Wong Ga-seng get is 0.68. Do you guys get the same answer? Okay. Then the resistivity 1 over rho, 1 over 0.68. What's the answer? Wu Heng Dong, what's the answer for this? 1 divided by 0.68. 1.471 something. 1.471. Okay. Simple and easy. Then go to the next question. Based on the result obtained from Q2A3, calculate the drift current density with the applied E32. So what you have to do is very simple. Okay, 0.68 multiplied by 32. So you can get an answer. 21.76. Okay. Simple and easy. Okay, drift and diffusion, I think we discussed a lot of time already, so I don't have to discuss it again. So let's go to the third question. Okay. Okay, there are four scattering mechanisms presented in the semiconductor material given that the net is 260 and for the respective 2000, 3006, and 4008. Then what is the mu for? Okay, those solution very simple. Mu total, mu1 plus mu2 plus mu3 plus mu4. Okay. Peng Xue Wen, what are the answer for the question 3A? Peng Xue Wen, are you here? You haven't done this yet. Teo Yisi, are you here? Mr. Teo Yisi. What is the answer for this question? 3A. Haven't do. Okay. Rong Yao Ting. Wait. Well, how come many of you still say haven't do one? Just now, I think most of you have done already, right? Forward haven't do. So I pick three of you. You guys tell me haven't do. So let's see which next one. Try you young. What are the answer for this question? Answer for this 3A1 mu 4. Okay, 349.65. Do you guys get the same answer? Okay, so this one very direct and simple. Just you need to hunt down the formula, then you should get the answer already. Okay, next question. The edge of the diagram displays the compensated semiconductor and its unionized and ionized acceptor and the donor. So what you have to do is you can refer to the slide number 5 or 6. I think it's 5 if I'm not mistaken. So let's see. So basically all you have to do is just to refer to this diagram, the complicated one, which is this one. So you just need to tell, okay, which diagram is the ionized with this location, ionize this and this, donor here, thermal electron, acceptor, thermal hole, something like this only. Okay, this will answer the question 3B. While the question 3C, with the arrow diagram, describe position of the Fermi energy level of P-type and the N-type. So to answer this question, you need to refer to this Fermi energy level, blocking somewhere around here, blocking somewhere around here. And for the further one, you can refer to lecture 4 if I'm mistaken. This one, Fermi energy level, P-type and N-type. Then this will give you the correct answer. Okay, nothing much. So let's go to the question 4A. Consider a germanium sample at T equals to 300K. The Hall effect device is designed with the following geometry. Okay, so let's see. D equals to 0.03 cm. W equals to 0.5 cm. L equals to 1.5 cm. Ix equals to 1.5 MA. Vx equals to 3.25. Bz equals to 6.5 times 10 to the power negative 12. Vh negative 11.25 MV. First question, determine the conductivity type. Is this the N type or the P type? Tiêu đồng không? For this question, 4A, is the N type or P type? Are you here, Tiêu đồng không? Or Khoa Yi Hằng? Are you here, Khoa Yi Hằng? Where are you, Khoa Yi Hằng? N type. Any reason why? Why do you think it's an N type? Khoa Yi Hằng. Yes, Mr. Khoa Yi Hằng. Why is this an N type? Yep, VH is the negative value, so that's why it's an N type. Okay. And then further to the next question, calculate the major carrier concentration. So when you're talking about the major carrier concentration, you always refer to this formula. Okay, this one, N. So since we know that this is an N type, you can use this formula. But one thing is you need to convert everything into the SI unit. Don't forget that. Okay, so N will be equals to IS BZ E D V H. So I ask 1.5 M convert to the SI unit, BZ already in. Then G constant, D convert to the SI unit, VH convert to the SI unit. Okay, so excuse me. Okay, for example, like this example, okay, you need to convert everything back to the SI unit always. Okay, so what is the answer for this question? So let's see. Pick some guy to answer. Wang Chongyi, are you here? Wang Chongyi? Mr. Wang Chongyi, are you still here? Okay, since there is no response, then I may ask another one. Dan Xinsheng. Are you here, Dan Xinsheng? What's the answer for this N? Remember, convert everything to the SI unit, then you can only do. Okay, so your answer is 1.81 times 10 to the power 20. I assume this one is in the M minus cube. Is it? You didn't convert back to the CM, right? Okay, do you guys get the same answer from your friend? Okay. Simple and direct. Next one. Calculate the majority correct mobility, which is this formula, mu n, I x L E N V X W D. Okay, you already get all the information here. I x here, L here, E constant, N calculated there, Vx is given, W given, D is given. All you need to do is to convert it back to the SI unit, then create. Okay, so let me pick some guys to answer this. Lim Yong Chuan, are you still here, Lim Yong Chuan? Yes. What's the answer for this? Mu n. Okay. 1598 cm square over Vs. Any plus one? Okay, thank you for the answer. Okay, so the last part basically is a photoresist, lithography, and etching. I believe you guys already know that in the lecture one. Okay, you can just refer to the answer. Okay, so this is how the exam looks like. But for the upcoming examination, please be careful because you are going to be like the test. We need to calculate the P and Q. So when you calculate P and Q, you need to be extra careful on that. And everyone will be having a different answer in this case. Okay, and so you can see that some of them are very direct answer. For example, like this, because this one is the still a physical face-to-face examination, but in the virtual examination, this kind of question will be lesser. Okay, calculation will be more. Okay, so far any question? So if no question, that will be the end of the lecture already. So all the lecture video I will be uploading it by this week. So there won't be any more lecture class. So I will say question 1, 3. I thought we already discussed it, right? Oh, okay. I missed this, is it? Have I missed this? Question 1, 3. This one. This one, is it? Okay. So let me see this back. Okay. So last time we calculate this. Okay. First part, we know that the gap is 0.55. Okay. EV, which is somewhere around E and then EF 0.55. Then the second part, okay, the second part will be E1 somewhere around here. E1, E2. What are the answer for E1? So for the energy gap based on this is the, okay, where this one is 0.55 plus E1. That's it. Oh, yeah, E1 is here, somewhere around here, to get the final answer. What's the answer for the E1 again? Yong Wing Liang, do you still remember that? Zero by 0.0673. Okay, so your answer should be here is 0.0673. Negative value because it's below somewhere around here. So all you have to do is 0.55 plus 0.0673. Add these two together to get the final answer. Okay, that's it only. Okay, have I discussed this question? Question 4, B4? Ada tak? B4. Anyone? Ada. Okay, sorry for the miss. Okay, so based on the calculate E1, I think you guys get the E1 is 0.06763, right? Okay, for the E1, do you get the same answer as the Yong Wing Liang first? 0.0673. Do you get the same answer? Okay, so basically for this question, very simple. Will not contain electron. It told you that. Okay, 1 minus 1 plus exponential. So this will be the negative 0.0673 KT. Okay, so this is more trick because this is from 300K to 500K. So we have to use the times 10 to the power negative 5 multiplied by 500 to get the final answer. Okay, then you can get the probability. So Long Yao Ting, what answer do you get for the last question? Long Yao Ting? Okay, your friend gets 0.1458. Do you get the same answer? Okay, very simple and direct. Okay, so basically this is all the questions. Sorry for leaving out these two questions because I forgot that. Okay, so at this point, any question? So if no question, good luck to your examination. So basically, it's not hard, I would say, but you just need to be careful. It's a little bit tricky. Okay, and then so the later the replacement class, you guys don't have to come anymore. Okay, we already cover all the content, and then for the upcoming tutorial class, I have also uploaded some tutorial question previously. Please try to complete it. So in the tutorial class, I will try to discuss the answer on the day. Okay. tutorial revision. This one, try to do copy all this question. Okay, basically just a revision to cover everything. Okay. So if no question, then I will try to end the class for today. Thank you for the attention. So if there's any offense in the lecture, I will apologize to you. So good luck and everything, and hopefully you can do everything well. Okay, in the upcoming examination. Okay, thank you very much, and have a nice day, nice weekend, and take good care of yourself. Okay, be careful of COVID. So you may leave the classroom now. Thank you.
Sir,
Yes,
I'm Jie here.
yeah, yeah.
Sorry to interrupt. I want to ask questions about next semester. Will we going back to college for the class or continue e-learning? Because the student that I didn't attend for.
Oh, okay. So at the upcoming short semester, there will still be the online class, but you also may notice that our government already announced we can go back, right? Go back to campus. So right
Yeah.
now, the step taken is we are going to gradually open it step by step. So we may let those essential class to attend first. For example, especially those who need the hands-on or the lab or those class to go back first. Then after that, we let the, let's say, a smaller group to come back. Then we only let the big group to come back. But everything just wait the notice. We will slowly open it.
Oh, okay. Because the other faculty they do receive like those specific courses they will need to go back or not will be hybrid or online like last semester what they did. So this semester also we will receive the announcement from faculty through intranet or somewhere
Yes,
else, right?
yes, yes, yes. Of course.
Okay. All right. Yeah. Thank
Okay,
you, sir.
okay. Thank you for the reminder. Okay, the rest of you, you may leave your classroom now. Thank you.